Hello everyone, January 27th. Alright, part 2. Let's keep going. So this is, we have the DP setup. So this is the second kind of way of doing it. I'm going to use count. So it's going to be DP count, which is the number of the length. I should say count, the length. I think length would be a better word. I'll call it length. So it'll be length and remaining pairs. So this will be length. So when pairs is 0, there's only one way, no matter what, right? There's always going to be 1. Because you have 0 pairs, it's always going to be 1. And now we say length is 1. Length is 1, we can do all this because I have 0. So the first row, first column will filled. Now, length is 2. Okay, length is 2 if we want 1, which, because if your length is 2, you can pick a small or you pick a big. If you pick a small, then that will be dp length of 1 and you want to do 1, right? If you pick a big, then you're guaranteed to have 1, so that will be dp 1 0. So we basically need to add dp 1, add these two together, right? So that'll be 1. Length is 3. Again, so we can put the smallest at the front, so that will be dp 2, right? dp 2. If I put the minimum on the front, that'll be dp 2 with a because you don't have any, so dp 2 1, right? Or you can put a second biggest, so it'll be dp 1 dp 2 0. So we cannot put it because it's already to 0. So we go up. So be dp2, add these together. So that would be 2. Now we go to dp4, right? So length is 4. So we can put the smallest. That will be dp3 1 and dp3 0. And then that's it. So we add these two together. That will be 3. Similar to 5. So it will be 4. Okay. Now we handle here 2 pairs. Okay. 2 pairs. So we're gonna go dp2. So we have 2, we need 2 pairs. So if it does small, so it will be dp 1 2 plus dp 1 1 plus dp 1 0. Right? They'll be adding these 3 together. Now 1 2 is a 0. 1 1 is a 0. Right? But 1 0 is a 1. Now, is this even exist? It does not, because we only have length is 2, right? Length is 2. So we can only add at most 2. So it will be the minimum of your length and the minimum of your remaining, right? Your remaining. Actually remaining plus 1, right? So in this case, length is 2, remaining plus 1 will be 3, so minimum is 2, so we do 2. Right, so dp1, we add from here, 2, that's a 0. So now we have length is 3, so now we can add all of these, because it's 3, right? So that will be 2. And then 4, that's also 3, so it'll be all of these, which will be 5. And this will be 9. Now coming here, again, so it will be 2 or 4, right? So because remaining plus 1 is 4. So we got 2. And then this we can add 3. So it'll be 1. This I can add 4. Right? So I add all of them, which is 6. And this adding all of them together, that's 15. So the answer I shall say is 15. So let's take a look, see if it's 15. If it is 15, then I think we have a solution. Is this 15? Yes. Okay, so that is a solution. So this is ON squared, right? Trying to, yeah, it's still gonna be ON. No, it's actually ON triples because I have to do all this. But we also realize that if we can keep a prefix sum here, right? That will make it easier. So every time we do a prefix sum, and if we do prefix sum, then we can do a range sum, because all we want is from here add all the way to, you know, some value. Which means if I do a prefix sum, I can, so this one will be a 2, right? This one will be a 3, this one will be a 4, this one will be a 5, right? And this one will be a 2, this will be a 5, right? And then this will be a 9, this one will be a 14. Okay, so now if I again go to the last one, this I add, so this I did 2. Now this is actually just going to be 1, 1, right, and then 1. Prefix sum, right? So this is always 1, this is always 1, the prefix sum. So here I need the sum of these two added together. So prefix sum wise, it's going to be this minus this, so that's a 0. And I'm going to add it, so this is going to be 2. And this I can add, length is 3, right? 3, so I add 3. So basically, I need these 3, so it'll be this minus this, so it's 1, and add it, so this will be 6. This is 4, so I can add a 6. Yeah, I do a 6, so this will be 15. And for here, I also add the 15. So 15, so this actually at the end, if we do it, it's going to be 29, right? 29. So to return the final result, it's going to be this one minus this one. Okay. I think we have a way forward. Let's implement it. Oh, come on. All right. So first things first, I probably need this one on the side to help me. So I need to create a DP. Okay. So for this DP, what do we need? What we need is a n plus 1 rows and k column. I'll just set everything to 0 times k for this in range. We need to n plus 1, right? So that's the DP. And then the first row is always going to be all ones, because this is 1, and then all of these will be 0. So I will fill the first row. I will say for I in range, actually I should say j, right? For j in range k, right? And we say dp what? dp 0, because it's zeros, and dp 0 and what? J, right? Oh, I think the way I said it is really not helping me. Equal to 1, and also the first column, right? So for I in range, that shall be n 1 to n plus 1, right? Because we do the length, and dp I 0, right, equal to 1. Okay, so now we set up the first row, first column. Now we're going to start from this thing. Then we say for I in range 1 to n minus, no, I should be 2, right? 2 to n plus 1. Let me also explain what dp is. Okay, so we say dp I j is equal to cumulative, right? Cumulative count of ways, right? No, as I can say this, equal to the count, the number of ways to create, what's it called? Inverse pairs, right? To create inverse pairs, number of ways to create inverse pairs, to create j or fewer, right? J or fewer inverse pairs given a length of I. Okay, that's what that is. So now I have the j I. Right now we'll go for j in range. That's gonna be from 1, right? Come from 1 all the way to k. Oh, shouldn't you do k plus 1? My bad. I think this should be k plus 1. Yeah, it should be k plus 1. Okay, this is k plus 1. And this has to be k plus 1. These are fine, right? K plus 1, we get everybody, and this, yeah, this is fine. So this is gonna go to k plus 1, okay? And for each one, that is going to be, so dp I j, right, shall equal to dpij shall equal to this minus everything to the left, right? So that's going to be dp I minus 1 and j, that's that, minus dp I minus 1 something, okay? I don't know what this something is. That shall be j, right? J is the current, because it's the minimum length. We need to do this length, right? The length, so it can be minus something, okay? And that something, first of all, we're gonna create we can say that's the, call it what, temp or length, or allowed. We can say allowed will equal to the minimum of your length. Now the length is I, right? That's the current length, because we do the minimum of the length and the remaining plus 1. Remaining is your j, right? Remaining plus 1. So I and j plus 1. That's the minimum to go back, right? Now in this case, because there's 3, there's 2, so minimum go back is 2, right? We go back 2. So which means what I need to know is the sum of these two. Hold on, is that right? So I'm here, right? I'm do 3 2. Length is 3, so I cannot go more than 3. And then 3 and 3. So 3 and 3, we just add this one. So this is allowed. So it's gonna be this 1 2 3. So it's gonna be j minus allowed. Right, j minus allowed. And if it's allowed is 2, we minus 1 is 2. Okay, j minus allowed. And also if j minus, right? So we're gonna say if j, so we do this, if j minus allowed is large equal to 0, else 0. If j minus allowed, we shoot too much to the left, then that's going to be a 0. And then we do this to give it the sum, okay? So dpij equal to this, and we'll keep doing this, blah, blah, blah. Then we'll be done with this, and we can just return. That's going to be the last row. We can call it dp minus 1. minus 1, the last row of the last one, because that's added together, and we need to do that minus the last row and minus 2, right? We need to do this minus this. Okay. Time to take a look. Let's put in the test case and have a couple more. 5, 3. Now let's go like 1,000. N is 1,000 and K, let's say 1,000 pairs, 500 pairs. Oh, and index is out of range. Ooh, that is rough. Which one? Index is out of range. Maybe K is equal to 0. Yeah. Oh yeah, it might not have minus 2. Okay, so we'll minus this. Okay. If K is 1, I have minus 2. So if K is larger than 0, otherwise we do 0. Okay, like that. Ugh. All right, that's not right. We have to take a look. Okay, it's okay. It's okay. Let's see. What does this one return? Huh. That's all right. That is fine. We just need to debug this thing. Okay, so what I need to do is at the end I want to print out. So for row in DP, I just need to print row. Okay. It's 27. Ooh, that was bad. That was so bad. I think I forgot a plus. That is for sure. I forgot a plus. And the second row is... That's not right, right? The second row. Minimum of I start with 2, J start with, so allowed to be 2, right? And 2, and then J is 1, so 1 minus this, if this L should be 0, and this shall be, why would it be 0 here? Exactly, why this one is 0? This one shouldn't be 0, because J minus allowed is large or equal to 0. I do J minus allowed. That is understandable. If it's, because allowed is 2, J is 1, smaller, this should be 0. This one should be 1. This side should be 1. Ugh, what went wrong here? I'll print IJ. Okay, I'll print IJ, and then I'll print, you know what, I'll print IJ, and I'll print dp. No, I'll print j minus allowed. Abort. Okay, I just want to know 2, 1, yeah. That's minus 1. I'll do this, and I'll do dpi and j. Why is 0? I don't understand. So I is 2, right? I is 2, because I is 1, go all the way down. Oh, I see. Line number 7 is wrong. This is not 0, this is 1. Plus, I mean, this is also has to be dp I j minus 1 plus. So I have to keep it like that. There we go. That's the one. Oh, that's not what I want. I can also say here, use prefix sum to quickly compute, to speed up the computation, right? To speed up the computation. All right, let's go back to all our test cases. 4, 2, 5, 3, 1,000, 500. Oh, I did not do the mod. Dude, you gotta do the mod. Mod will be done here. So mod 2, 3, 4, 5, 6, 7, 8, 9. I can do mod here. Minus, I think that's fine, right? Go to basically say this. Oh, is it wrap? I don't want auto wrap. Oh, it's another thing to handle. So this will be mod. Oh, minus. Damn. Okay. So allowed. I need to have more of a. Oh, we need to plus something and then mod. Okay. We'll call it additional. Current. So current will equal to. So basically we'll do from this all the way to here. So we'll take this away and then okay, I don't like this. Now let's go to the end, come here, take this away, and then we paste it here. Okay. Minus this, plus mod, then mod. Alright, this is really tripping me. No line wrap. no line wrap. Text if you prefer auto wrapping. A 0 value disables this. So we set it to 0, wrap margin. Oh my god, there's so many different ways to do it. Okay, which one to try? I have no clue. Let's try. Okay, let's try. Set text width equal to 0. Okay. Don't think it works. Set wrap margin equal to 0. Maybe that's not how it's done. Maybe set. Okay, set wrap. Oh, that did it. But how do I do this? Because if I quit it, it'll be wrapping again, right? So what I need is a NeoVim way to do it. No wrap. Okay, let's go here. Lua custom config. Yeah, I'll have to handle this symbol thing. Yeah, because it's waiting for bold. That's tripping me. I think I'll just type 2. You know what? I don't like this anymore. So I'm gonna GCC this. Ugh. So I will GCC this. I don't like this anymore. But I do like. Oh, I gotta. Wait, hold a second. Config. These are not supposed to be in the for loop. That's why it's slow. Why did I put this in the for loop? I have no clue, man. Yeah. Because I feel everything is just so slow. Well, it's because I put them in the wrong spot. They're supposed to be outside. And I don't have use for these as well. Right? I don't have use for this. So we do that. Then here's the config. No, that's the config for different thing. Options. I don't know. Vim dot option dot. What's it called? No wrap. Nope, it's not here. WO dot no wrap. Vim dot no wrap. Wait, how? How do I do no wrap in NeoVim? NeoVim. No wrap. How do I set that? No wrap. Wrap as local to window. Okay. I didn't see this. I did not see this. I tried. I say vim.wo. Maybe I need to keep going. No, there's no wrap equal to true. And I'm gonna call do not wrap lines. That's interesting cursor. What happened to the cursor? Why is... Wait, hold a second. What happened? Oh, shoot. What did you do, man? What did you do? Ah, screw it up. Come on. Okay. New. Let's bring it up. Go to... Oh, I can't even go to previous... Oh, shoot. Dot config vim invalid option, no wrap. Help, no wrap. Oh, probably you set wrap to false. Okay, let's try this. Where did I set it? Where did I set it? I set it here. So maybe it should be wrap. Okay, false. Okay, let's turn this off, turn this back on. There we go. That's good. Problem solved. And this shall be plus current, right? And if we go to the end of the line, okay, that looks all right. 16J, no, 16K, 27K. All right, let's go back here. Run this. No, it's not right. It's not right. 1, 2, 5, 15. I think is the last one. I need to plus mod. Right? I need to plus mod. Then mod. There we go. There we go. There we go. Nice. Got it. It's a decent DP, but not that hard. It's only actually it's decent. It's a decent nice. Right, and then we do this. Yeah, what delete. And if I do this, there you go. It's good. That's all I want. That's all I want for now. Maybe I want an automatic. Maybe we can try automatic. But if you do automatic, if I do this and okay, if I do this and I'm automatic close it, then I want to get out of it. There's no way for me to get out of it. Well, I can do this. Oh, S is delete the current one, so that's not what we want. Right, so we're, let's say after we do this, or if I stop here, yeah, what if I do this and then we stop and I just do an I to come in here, or I can do this. Okay, that's a new thing to try. All right, use DP to solve this problem. And prefix sum to speed up. Yeah, the DP rule is that dpij, dpij is the number of ways to create j or fewer inverse pairs. I'm just copying the same thing I wrote earlier. Given an array of length I. Now the important insight is that the actual values in the array does not matter. What matters, because each number is unique and there is always a deterministic order given an array of any size. That's n k, right? O n k. Yeah, we scored a decent one. That's decent. We actually take a look at our previous solution. Oh, we can do it with that's interesting. I think we need to take a look again. Did we use the... Wow, I was not able to solve it the last time, but this time I can do it. So that was an improvement. That was good. But this seems to be even better. I'll take a look at this later today. But that will be it for right now.